I am Dr. Ramesh, Associate Professor of Physics, Department of Science and Humanities, Sri Muthukumaran Institute of Technology, Mangadu, Chennai. Today we are going to discuss about laser. Objectives of laser, introduction, properties of laser, basic concept of laser, types of laser, NdYAG laser, neodymium, yttrium, aluminum, garnet laser. We discuss about in detail in this lecture NdArc laser and its applications. Laser, light amplification by stimulated emission of radiation. Introduction. What is light? Light is energy in the form of electromagnetic radiation. How light is produced? Light is produced through the process of emission, that is when the atom or electrons transfer from higher energy state to lower energy state, that is the emission. Higher energy state atom return to the ground state, two possibilities. Number one, spontaneous emission. Number two, stimulated emission. Spontaneous emission is nothing but the atom in the excited state return to the ground state spontaneously. Stimulated emission is nothing but atom in the excited state return to the ground state with some triggering the energy. The excited state atom cannot stay longer time there, up to 10 power minus 8 seconds only stay there. Then return to the ground state emitting a photon of energy E equal to h nu, quanta of energy, bundle of energy or packet of energy is called as photon. This is laser. The word laser expansion, light amplification by stimulated emission of radiation. The first letter is denoted as laser. What are the characteristics of laser? Laser differ from conventional light source in number of ways: monochromatic, highly coherent source, highly directionality, highly intensity. This is the characteristics of laser. Then main point is what are the conditions to achieve the laser action mean? Number one, creation of population inversion, stimulated emission, then suitable active medium. This basic parameter of characteristics monochromatic. The monochromatic is a highly single wavelength with single color, that is the monochromatic. This directional is a unidirectional laser source. The monochromatic single color means green color, example 5461 Armstrong, only one wavelength. But ordinary light spreads all direction, multi-directional, then different colors, violet to red. Coherent source. Coherence is nothing but lasers is a very coherent source, very thin, narrow beam, same phase, same amplitude, constant phase difference. The picture shows that coherent source of lights. Directionality. Highly directionality. An ordinary light spreads all direction, that is a spontaneous emission, but laser emits only narrow direction due to stimulated emission. The angle of divergence of laser beam is very small. Divergence very small means directionality higher. Highly intensity of laser, intensity is very high intensity. Example, 1 milliwatt power of helium neon laser appear to be 1000 times better than the sunlight. This is highly intensity. Next one is very important, population inversion. We already discussed about three conditions are main important to achieve the laser action. Number one, population inversion, stimulated emission, suitable active medium. Population inversion is nothing but the number of atoms in the higher energy state greater than the number of atoms in the ground state is called the population inversion. The picture shows that the excited state atom, so more number of atoms stored compared with the ground state, that is the population inversion. Basic components of laser: active medium, active center, optical resonator. Active medium is nothing but which medium to achieve the population inversion, that is the active medium. Example, solid state laser, neodymium, yttrium, aluminum, garnet laser. This is a solid state laser. NdYAG rod is the active medium. Ruby laser, ruby rod is the active medium. Gas laser, carbon dioxide laser, carbon dioxide gas is the active medium. Helium neon laser, helium neon gas mixture is the active medium. In semiconductor laser, PN junction diode is the active medium, and dye laser, some chemical dyes as an active medium. Active center, which material, which atoms are raised to the excited state to achieve the population inversion is called active center. This is the best example of helium neon laser. The neon atom is the active center. Optical resonator is nothing but acts a feedback system. So one side 100% reflecting mirror connected to the another side 50% reflected mirror. 50% reflecting mirror means 50% aluminum coating. Methods of achieving population inversion, pumping mechanism. The process of electron move from ground state to excited state by external energy is called pumping. This is the pumping method. It depends on the nature of the active medium is used. Example, optical bumping, solid state laser, NDYAG laser, ruby laser used in this technique, optical bumping. Electrical discharge method is the carbon dioxide laser. Direct conversion, PN junction diode, direct band gap of semiconductor. Inelastic atom-atom collision, helium neon laser. Optical bumping. Here the atom or electrons are transferred from ground state to excited state by photon. Xenon or krypton flash lamp focused on the rod. This process is called optical bumping. Example, ruby laser, NDYAG laser. Types of laser. Solid state laser classified into two types, ruby laser, NDYAG laser. Ruby rod is the active medium. This pumping mechanism, optical bumping. NDYAG laser, neodymium, yttrium, aluminum, garnet laser. NDYAG rod is the active medium. Pumping mechanism, optical bumping. Gas laser, carbon dioxide laser, carbon dioxide gas mixture is the active medium. Helium neon laser, helium neon gas mixture is the active medium. Semiconductor laser, gallium arsenide or indium phosphide laser. Now discuss about the NDYAG laser, solid state laser or doped insulator laser. What are the characteristics of laser? Doped insulator laser. Doped means yttrium Y3 plus ion doped with YAG rod. Active center neodymium. Pumping method optical bumping. Pumping source xenon flash lamp. Optical resonator. One side 100% reflecting mirror, another side 50% reflecting mirror. This is the NDYAG laser construction. The active medium is made as a rod which has yttrium, aluminum, garnet doped with rare earth metal ion neodymium Nd3 plus ion. The rod is placed inside a highly reflecting elliptical cavity. A close optical coupling is made by placing the xenon flash lamp. Usually xenon or krypton is used nearby the laser rod in such a way that most of the radiation from the flash tube pass through the laser rod due to the elliptical cavity. The flash tube may be switched on and controlled with the help of a capacitor. The discharge of capacitor is initiated using a high voltage source. Working principle of NDYAG laser, doped insulator laser. Yttrium, aluminum, garnet doped with neodymium atom. First, the working principle, point number 1, the flash lamp is switched on, the light fall on the laser rod. Nd3 plus ion rise excited from ground state to higher energy level. Due to the optical bumping, these ions are go to the excited level E3, above E3. They gather in the metastable state E4, where population inversion is achieved, stimulated emission build up rapidly. Finally, during the transition from metastable state to E1, the laser beam of wavelength 1.064 micrometer is emitted. This is the NDIAC output. Energy level diagram of NDYAG laser. This NDYAG laser, 3 more energy level, E1, E2, E3 energy level. Then E4 is a metastable state, E0 ground state energy level. E3 to E4 level is a non-radiative decay. E4 to E1 is a NDIAC output 1.064 micrometer. Then E1 to E0 is a non-radiative decay. Applications of NDYAG laser, the transmission of signal over large distances, long haul communication, endoscopic applications, remote sensing radar and lidar. Long haul communication. Long haul communication is nothing but optical fiber communication system. Optical fiber is nothing but guiding medium. Communications send one place to another place. This is the one side transmitter, another side receiving end. In between the transmitter and receiver, optical fiber cable is connected. This is the principle of total internal reflection. The laser light passed allows the optical fiber core medium. This pass to the another end. This is the long haul communication. It connected the wide area network and local area network and everything. Remote sensing, radar, radio waves detection and tracking, light induction detection and tracking. This is the remote sensing. These techniques provides broad view of monitoring climate and understanding ecosystems, integrating with geographic information systems for analysis. Another one important applications, medical endoscope, laser treatment in kidney stone. Kidney stones are destroyed or removed by applications of laser. Thank you.